Good morning, everyone. My name is Eric Romo. I am the DS23 tutor at Fresno City College, and today we'll be talking about the uniform distribution. So, in a uniform distribution, we actually have a specific shape that our distribution follows. So, right here, I have this little graph going that has a rectangular shape, and this function is defined as 1 over d minus c for the interval between c and d, that is x. So, and my mean that I get from this is equal to c plus d over 2, and our standard deviation for this function is d minus c over the square root of 12. So, if I want to know something and that follows a uniform distribution, let's take this practice problem. What is the mean, standard deviation, and probability of a 4-minute wait time for an elevator that follows a uniform distribution? Well, I already know my interval, which is between 0 and 4, so I need to denote this as C and D. So I'm going to rewrite my function down here as 1 over d minus c is 4 minus 0, so that would just be 4 for the interval of 0 and 4, and 0 otherwise. Now you're probably wondering, what does that mean, 0 otherwise? If we think about it, if there is any other wait time that is past 4, the function will not occur, or our f of x, our outputs, will be 0. So if we notice here, between 0 and 4, 1/4, which is what we just defined, is our height of this rectangle. And over here, past 4, it's 0. And if we were to draw a negative wait time, which really would not happen in real life, but it's also 0. So, if I wanted to find out my mean, or average wait time for an elevator, I just need to plug it into this function for my mean. Mean is equal to 0 plus 4 divided by 2, which is equal to 2 minutes. So the average wait time for this elevator is 2 minutes. Now let's find out my standard deviation. And that is d minus c over the square root of 12, which is 4 minus 0, which is 4, divided by the square root of 12. I'm not quite sure what that is, so let's go ahead to the calculator. Right. And I'm going to put in 4 divided by, parentheses, this square root of 12. Oop. Didn't put it in right. 4 divided by parenthesis 12 square root, close your parenthesis, and hit enter. And I get 1.1547. Okay, so that is our standard deviation from the mean, 1547. Alright, so why did we figure all of this out? Well, it's because in a uniform distribution, we can figure out also the probability of landing within this rectangle. So how do I do that? Well, recall back in chapters 1, 2, and 3, we were given x bar plus or minus ks, which is the interval of which this lies. So, if my mean is x bar, because this is a sample notation, let's do a population notation, which is mu plus or minus k of baby sigma. I'm going to take my values that I just solved for and put them in. So I have 2 minutes here plus my standard deviation, which is 1.1547. And then I have to do the minus also. 2 minus 1.1547. So the probability here, my upper and lower bounds of probability, let's go to, let's see. I know that my upper bound will be 3.1547. 3.1547. And my lower bound, not quite sure what 2 minus 1.1547 is off the top of my head. 1.1547 is 8.8453. So I'm going to go ahead and write that. 0.8453. Okay. And so with this interval, I can now multiply 3 minus 3.1547 minus 0.8453, which is equal to, where's my calculator? Oops, sorry about that. 3.1547 minus 0.8453, which is 2.3094. Okay, and so why did I minus the upper bound from the lower bound? It's because I want to find out the specific area that my probability will land in. Well, if I am using the bottom interval, this is an area, so in order to find the true area, I need to do base times height, which is also the area for a rectangle. So I have my base. Now I need to use my height, which is 1/4. So if I times 0.25 and multiply that by 2.3094, I will find out the probability of landing within those intervals. 2.3094 multiplied by 0.25. And the probability is 0.57735 of success. Take the complement of that and you'll find your rate of failure. And that's all there is to it.